Hello class. So we have a test coming up tomorrow, so it's important that we review everything that we've done this week and we kind of hammer down some things maybe that you're not so sure of, so we can get ready for tomorrow. So let's review kind of what we did this week. We learned about points, lines, and planes. We learned about the terms and how they make points, lines, and planes then define all the other terms. We actually did some constructions hopefully on them. If not, then don't worry about that. We also talked about postulates. Remember postulate 1-1. If 2 points intersect, if there's 2 points, there's only one line that can be formed between those 2 points. That's postulate 1-1. Postulate 1-2. If 2 separate lines intersect, there's only one way it can intersect at one point. That's it. And then 2 planes. If you take 2 planes, imagine my second arm is a plane. If they intersect, they form a line. So 2 planes intersect at a line. And the last one was 3 non-collinear points can make a plane. Only 3 non-collinear, remember non-collinear points make a plane. Alright, so let's now go over a couple examples of naming and things like that. Make sure if we're naming on the right track. Number 1. Now forgive me if mine's a little bit different than yours, just bear with me. If not, we can make sure your answers are right tomorrow in class as a further review. Name 2 intersecting lines here. I'm going to go with QR is going to intersect with RS. So I say QR and RS. Now I'm using a segment symbol. I don't really like their question of intersecting lines, but I'm going to say that line segment QR and segment RS intersect. I could say segment AB, segment and BC, etc. Any 2 lines that intersect or touch are going to satisfy that answer. Name the intersection of planes QRBA. So I'm going to outline that as it's red. QRBA and plane TSRQ. As you see, where do those 2 overlap? At QR. So those 2 planes intersect at segment QR. Now, I know that postulate says they form a line, but this is a contained box, so I'm just saying segment QR. If you say line QR for right now, I'm fine with that, but that's where they're going to intersect, those 2 overlapping. Our last question. Name 3 non-collinear points. I just want 3 points that are not on the same plane. Think of a box. Visualize a 3D box in your head. Make that into this. I'm going to pick 3 points that won't touch each other. So I'm going to say BR. So I know they're touching each other. They can be on any plane, but what's one that's not on there? I can say all the way back at the box, T. T is not on the same plane as those. Visually, I can cut through the box, but right now it's not on that plane. Okay? As we saw earlier. These are 3 non-collinear points. I could say BR and BR and T or BR and D right now. Those are the ones that don't have are on the same plane. Sorry about that, guys. Real quick before we go into this, I'm just doing another quick example about angles and the measure of angles. Here it says the measure of angle AOB is 47, so I'll mark that. And it says the measure of angle BOC is 73 degrees. Now, it wants to know what's the measure of angle AOC. Angle AOC is this whole thing. So I need to know it's this plus this. So it would be angle AOB plus angle BOC. So 47 plus 73. And what's that equal? 120 degrees. That's called the angle addition postulate. If you add those 2 angles, that's the bigger angle. So angle AOC equals 120 degrees. Alright, our last example here. I have this figure here, as you see named. This is vertex Q, and it's broken up into a bunch of angles here. I have the measure of MQR is 61 degrees. So I know that from here to here, I'm going to put in blue, is 61 degrees. Now if I miss one of your problems, try it first and then come back to this. I know it's a jumbled up, I'm sorry for that, so we'll talk about all this tomorrow and we'll clarify before we get going on the test if you have any issues, so don't freak out. Measure of MQR is 61 degrees and the measure of MQP is 25 degrees. So I'm going to put that in black just so we know that's different. MQP, if I can open this, MQP is 25 degrees. So, what is the measure of PQR? I'm going to put that in green just like it's asking. It wants to know PQR, which is this part. It gives me the total and this part. So, if it gives me the total on a part, how am I going to find the other part? I'm going to use subtraction. So I'm going to take the bigger number, subtract. So 61 minus 25. So I get 36 degrees. Because this is the bigger angle at 61, and this one's a smaller angle, 61 minus 25 equals 36. Now I'll erase that. We'll go on to our next problem. If the measure of NMQ is 2x plus 8, NQM is 2x plus 8, and the measure of angle PQR is x plus 22. Now, in order to do this, we got to think back. What do these arcs mean? Think back. It's a symbol. It should jump right out at you. It means that those two are congruent to each other. Remember, congruence versus equality. Congruence means they're the same. So I know that these two are the same. So what I can do, and it's the measure, so it's actually equality. I'm actually going to move, since I know they're equal to each other because it deals with a relationship of sizes, I'm going to move this over here, draw the arrow, and I'm going to move it over a little bit, or check if you can see me. So, I know that 2x plus 8 has to equal x plus 20. So I'm going to do that in green just like the problem. 2x plus 8 equals x plus 22. Now, it's back to algebra. Hopefully we've done enough practice so you can do a problem like this. Here, I want to move my variables first. I usually move my smaller variable and move it over to combine with the bigger variable in terms of the side. So, I'm moving x over. So I got to subtract x on both sides. After that, I'm left with x plus 8 equals 22. Because the x's go away here, 2x minus x is x. My last step, as we should know, would be minus 8. I subtract 8 on this side, so x will equal 14. So that was a little algebra review for you. Remember, the arcs here represent that they're congruent. When we have segments, it's the little hash marks. I'll even draw one for you. Draw right here. The hash marks tell us that these are equal, and that would be my midpoint. So, these are the examples. If you need some more examples, go online, check it out, points, lines, and planes. You can check out our textbook. I should have given you a code by now. We reviewed everything I think about points, lines, and planes. If you have any questions, go through your notes, go online. We will talk about it tomorrow. Okay? Remember, if I mess you up with any of the questions being different, we can clarify that tomorrow. We'll have plenty of time. I'm only planning on maybe a 25, maybe 35-minute test, so we'll have 10 minutes for review. Okay? Good luck, study some more, and I'll see you tomorrow.